film this. Might as well start the video. Yesterday we proved that if you take any parallelogram, so any old parallelogram, and draw a diagonal line across it, that those triangles are congruent.
Well, they're same side.
That's what we did. Or, I mean, and it doesn't matter, you could draw it this way and ignore that one. Then those two triangles are congruent. We did a proof of that yesterday. If you would like to do it again, you can come in after school and we can do it. It's a very exciting proof. It's very riveting. If you don't want to, that's okay. Because we're going to do another one today. But we're going to talk about kites.
Isn't kite the same thing?
A kite? Remember what a kite is?
Yep.
It's a kite.
It's the same. I have my lesson using right?
I don't know about that.
Give me time.
It's that. Those two sides are the same and those two sides are the same, right? Alright. So our problem says Kip shared his findings about his kite. What? Oh, we skipped a problem. Oh well. Basically what we're going to do on this kite. Remember yesterday we took the parallelogram and we drew a diagonal line across there? Those are just called diagonals when you draw from one corner to one corner. So we're going to do the same thing with a kite. We're going to draw in the diagonals. So we're going to put a line from that corner to that corner, and that corner to that corner. And I'm going to let you make, it's called a conjecture. It's basically just a guess about what might be going on there with those two diagonals. And then we'll see if we can prove your guess. So, does anyone have a guess about how these two lines, these diagonals, might be related or what might be going on? You have a guess. You're already on. What?
The angles might be related.
What angles?
The one where they connect, intersect.
You say the one? Maybe. You saying these might be equal?
Yeah.
Yeah.
Okay. We could prove. We want to try to prove that.
Yep.
Or is there anything else you want to? I'll let you pick which one we do. Is there anything else these might come in related?
Well, if you part it in the middle, two sides are the same too.
What?
If you part it in the middle, the two sides are equal.
Those two are the same? Maybe. Okay. I'm talking about more of just like the lines or the angles, not the triangles. We're going to use the triangles though, so that's good to know. So would you rather prove that these angles are equal, or do you think that maybe these two, that at this diagonal split that one in half, and that those two would be the same?
The angles in the middle are going to be equal when you
Let's do that, Ed. Let's try to prove that those two angles are the same. And in fact, let's prove that they're not only the same, but that they're right angles. What do you think? Think we can prove that?
Yeah.
Okay, here's how we're going to do this. We're going to use the triangles. So what I'm going to do is, I'm going to take this kite with these diagonals, and I'm just going to focus on that top piece. So I'm going to redraw that. So I have that. Whoops. So let's put some letters on this thing. I'm never very creative with this. Hello? No? No? Okay, bye. That's weird. So we want to prove that angle ADB equals angle BDC. If they're equal, how many degrees would each one be? This is a straight line, isn't it?
Oh, 180.
Yeah, that's a straight line. That's 180. So if these angles are equal, what's each one have to be? Yeah, you said it. 90. Right? You can't have 89 and 91 because then they wouldn't be equal. Don't they need to add to 180 and be equal?
Yeah.
So they'd have to be 90 each. So basically, we're proving that these are right angles. And to be able to do that, we'll prove that they're equal. How can we prove that two angles are equal? Let's see if anyone can think of this. Like Linda, maybe she might know something. How are we gonna prove that those are equal? Or Annie, you might have some insight. Remember how to do this?
Try your knowledge with it.
Kinda. It's been a while. It's been like 6 months.
Did Michael fight for this one?
Michael fight. Oh yeah, this is the one where he was arguing. I can't remember which that one's about.
Try your knowledge with it.
The way we could prove that these angles are equal is this. If we could prove, Jenny, didn't you say you thought those two triangles were congruent?
Yeah.
If we could prove that those two triangles are congruent, doesn't that mean that those angles would have to be equal? Because don't congruent triangles have all the same parts? So let's try to prove that those two triangles are congruent. You know how to do that, don't you? You know how to prove that triangles are congruent? Okay, so let's try that. Let's prove that these are congruent. Do we know anything?
Yes.
What do we know?
The two hypotenuses are equal.
Don't call them that yet, because you're assuming that
The legs.
these are equal, aren't they? How did you know that?
Because it's given.
Yeah, it's given. It's a kite, so we can call it given. Yeah, it's a proof. So our first circle will be AB equals BC. And the way we knew that, it was, you could write, I don't know, definition of a kite. You already have this one written in your notes. Yeah, because this is a kite, those have to be equal. So that's the proper way. We should probably write that. The definition of a kite. Because that's a kite, I know that those are equal.
Can we put like abbreviations on the answer?
Yeah. Most of it's multiple choice, so they'll have it all written out for you. But there are a few where you will have to do a proof, and I think it's fine to abbreviate things.
Is it going to be on a computer? Or
I don't know yet. I asked that same question a few days ago, and the lady who I asked did not know either. So. They had talked about doing them on computers this year, but I don't know if that's going to happen. Okay, what else do we know?
about B and D?
With the line that A and D must be equal to D and C.
A and D must be equal to what?
Or B and D is the same.
Oh, isn't BD the same as itself?
That's what I said.
Yeah, so that's the same in both triangles. So we got BD equals BD.
Is that what you're trying to say?
What's the reason for that? Do you remember from yesterday? What do we call that when one line is the same as itself? Reflexive property. Yeah. Remember that.
But then isn't it AD is equal to DC? So that's equal 180.
AD equals DC. How do you know that for sure?
You said earlier that
Straight line.
180.
Well, yeah, it's a straight line, but how do you know that this one cuts it right in half? Because that's what. Huh?
It's equal.
What's equal?
B and D is separating A and D, and D and C. And then
How do you know that? You may be right, but you don't know that for sure. And is this where Michael and I started arguing about that?
because you said it was going to equal, well, you're saying that it's going to equal 180.
Yeah, those two angles will equal 180. That doesn't say anything about those two sides being equal.
That's the line. Am I right?
I mean, I don't want to say you're wrong, but we can't use that for our proof. We have to have know stuff for sure to use it. There is one other thing we know for sure, and it's up here with these angles. When you draw a diagonal through something, you're creating equal angles. Because a diagonal, have we talked about the word bisects? Yeah, we have. Bisects? You know what a bisector is? An angle bisector? Can we talk about that?
No, we saw it on the test and we didn't know what it was. Yeah.
Oh, I thought we talked about that. Okay. When you draw a diagonal like that, you're bisecting that angle. And bisect means to cut in two. Cut. I thought we talked about this. 2 equal parts a long time ago. So maybe you don't remember.
That's it.
To bisect means to cut into 2 equal parts. And when you draw a diagonal, you are cutting it exactly in half like that. So these angles are equal. So we could put that on here. Angle ABD equals angle DBC. And your reason, I don't know. Yeah, that, just put bisector.
That's why that's the most boring week.
That's why it's the most boring week. Do we have enough to know the triangles are congruent?
Yeah.
Side angle side, boom. All right, so here we go. We got to come down here and we'll say, now I know triangle ADB is congruent to triangle CDB. What's the reason, Nando? What's the reason? How do I know these are congruent? Just copying this down ain't gonna cut it. If you're, no, I'm saying that's not enough. If you're not thinking about it as we do it, you're never gonna make it. You're just side equal side. Are we done? What were we trying to prove at the beginning? That these angles were equal. Do we have enough information to know that they're equal now?
Yes.
Yeah.
Yeah. Because if 2 triangles are congruent, doesn't that mean that all the sides and all the angles are the same?
Yeah.
Isn't that what congruent means? So I know these 2 triangles are congruent, right?
Yeah.
So doesn't that mean those angles have to be the same? So now we can draw another one down off this and say, angle ADB must be equal to angle BDC.
Oh, I messed up.
How do I know that? Someone want to tell me in their own words? In their own words. I don't want you to. How do I know that? What? Because the proof? How do I know that those 2 angles are equal? I already said it. I just want someone else to spit it back out.
The bisector?
Because what? What are,
Triangles are congruent.
the triangles are congruent, so what?
That means all the angles and all the sides are equal.
That means all the side angles and all. Can you sum that up into like 5 words, Linda?
Yeah.
What?
Congruent triangles have congruent parts.
Yeah. That's it. You're going to write that a lot from here on out. Congruent triangles. The reason I know those are equal is because congruent triangles have congruent parts, don't they? That's what we put down here. And we don't have to write out congruent triangles have congruent parts. How'd you know that? C, G, H, C, P. Congruent triangles have congruent parts. You could go congruent triangles have congruent parts. You could go, I think the EOC and the NBA, they write congruent parts of congruent triangles are congruent. Those all mean the same thing. It means if 2 triangles are congruent, all their parts are congruent.
I feel like that's like
One of these are all the same. They all mean the same thing. It just means if you have two triangles that are congruent, all the angles and all the sides are the same. So, alright. So what do we know about the angle or the diagonals of a kite? What did we just prove? If you have a kite and you draw the diagonals, what do we know about them? The diagonals are these lines.
That they do separate the name,
What did we just prove?
that they're congruent.
That what are congruent?
The angle.
I'm not asking you about the triangles. I'm asking you about these lines. What did we just prove if we draw in the diagonals of a kite? What happens?
They're 90 degrees.
They intersect at a 90-degree angle. That's what we just proved. Because if these are equal, they have to be 90. Would you say that these are equal right here, these sides?
Yeah.
Because of the same proof, if those triangles are congruent, don't those sides have to be congruent?
It's always right about the triangle being
So if you draw in the diagonals of a kite, it's perpendicular bisector is what it's called. Kind of weird.
The two bottom ones are equal too.
These triangles?
Yeah.
Yeah, we could prove that. They would be congruent. Aren't proofs fun?
Yeah.
Woo! Yeah.
We do the right.
Freaking pumped up over here, man. This is like. Let's do another one. Yeah. Let's do a rhombus one. Let's get crazy. Rhombus. Let's do a
So
rhombus.
excited to drink water. Man, this is a workout for the
I
brain.
know, I'm almost sweating. I might be sweating after this one. You'll have all of these.
Are rhombuses and kites kind of the same thing? A little bit.
No, because kites, where'd that paper go? Kites have, those two sides are the same and those two sides are the same. But a rhombus, remember what a rhombus is?
All sides the same.
All the sides are the same, yeah. So for a rhombus, yeah, all the sides are the same. So what do we want to prove? We could prove that all the sides are parallel. Not all the sides, but that that's parallel to that and that's parallel to that. But that one's boring. We won't do that one. We want more excitement in our lives. We already know that. Let's do the diagonal thing again. Rhombus. So here's my rhombus. I'm going to draw in the diagonals.
So we don't put the lines.
Boom. What do we want to prove about those diagonals?
The angles are
The angles are 90 degrees. You want to see if we can do that again?
Yeah.
Let's see if we can prove that that's a 90 degree. Does it look like it's 90 degrees?
Yeah.
No.
Yes.
Let's see. Let's see if we can prove it. Let's see if we can prove. I'm going to take this and cut it out again. So I'll just take the top. It'll probably look like 90 degrees when I draw it this way, but let's see if it is. We'll go A, B, C, D. Let's prove that the angle ADB equals 90 degrees. We can do this. Pretty much the same thing as the other one. If we can prove the triangles are congruent, Doesn't that mean that these must be equal, so therefore they must be 90? Okay, so let's do it. Let's prove the triangles are congruent. You want to try it on your own?
No.
Yeah. It's the exact same thing if you
It's pretty much the same thing.
On my paper, you did the diagonal lines, you put up the diagonal lines equal.
Prove that. Oh, prove that they bisect each other?
Yeah.
We could do that one too. Yeah, let's do a different one. This is the same thing as the other one. Let's change it up.
Let's do the hexagon.
Let's prove.
Let's do a dodecagon.
Let's prove that AD equals DC. That's what we're gonna prove now. Because I think that when you draw the diagonals, they cut each other in half. I think that's equal to that,
Can we do this by ourselves?
and that one's equal to that. No, I'm gonna go over it with you. Then you'll have your. Then I'll give you your homework. Homework. Yeah.
The AD and EC.
Okay, we're gonna prove those are equal. Same idea though. If we could prove the triangles are congruent, doesn't that mean that those have to be equal? So let's try to prove the triangles are congruent. What do we know?
Line AB is equal to line BC.
BD.
AB equals BC.
Yeah.
How do you know that?
Given.
Better. Give me a better reason. Definition of a rhombus.
Does that mean we can't put BD equals BD because of reflective property in there?
Yeah, you can still do that. Yeah, remember this was a rhombus over here, and a rhombus has all equal sides, so I know those two must be equal. So that's definition of a rhombus. What else do we know? BD equals BD. This is pretty much the same. How do you know BD equals BD? Reflex. There's an X in there. Reflexive property.
Reflexive.
That's the word.
That was reflective.
No, reflex. And what's the last thing we know?
The one you bisect.
Yeah, this is the same thing. That angle's the same.
Look at that magic.
Angle ABD, D equals angle DBC. And it was a bisector. Therefore, triangle ADB is congruent to triangle CDB. Same reason even. Tomorrow they won't be the same. We'll do some different ones. Don't worry. I know this one's. It was very exciting the first time. The second time you're like. Side angle side. Okay, the next part's not the same though. Well, yeah, it is pretty much. I've proved the triangles are congruent. What's the last step?
Input.
What were we trying to prove?
Line AB.
Whatever you were trying to prove should always be your last bubble, right?
Yeah.
We were trying to prove AD equals DC. Have we done that? I think we have. I think AD equals DC now. How do I know that AD equals DC? Because congruent triangles have congruent parts. That is correct. Congruent triangles have congruent parts. So on any rhombus, if I draw the diagonals, what do I know? Turns out they'll both be the same. They bisect each other and they're right angles. You know what? Remember what bisect means? Split into two equal parts. If two lines cross at a right angle, what do we call them? Perpendicular. So we could say that the diagonals of a rhombus, diagonals those are, this is a fancy word here, words, perpendicular bisectors.
How do you remember this stuff? Just there? Or what?
It's just there, dude.
You guys have them.
Every year, same.
I feel like I'd forget. I'm not gonna remember this tomorrow. Or by the end of the day.
So long you have a test.
Do it enough times and
Does Mr. Voss know what?
No.
Like, you'd feed him at a math test.
so here's your assignment. No. I don't know. We should have a challenge. We should have a math competition.
You and Mr. Voss? 100 questions, 50 seconds.
There's the assignment.
When you cheat.
You need sheets? Yes, you do. I'll pass out some new ones. Alright, video's over.